Hello.
Hey, I'm Oops, he's Dustin, and we're Team Enginerds.
All right, we're going to do a quick presentation on how to construct a tower out of spaghetti noodles, marshmallows, and a styrofoam block.
So we have our styrofoam block right here. We'll use that as our base.
So what you want to do is you can either start with 4 posts or 3 posts. We're going to do 4 posts because we want to demonstrate some different cross bracing on each side to just kind of give you a overview of what direction your students might go. This is kind of the first step.
Yeah, you want to make sure the noodles are inserted in straight and they're not crooked.
All right. So the next thing we've done, I'm going to do is we're going to slide 2 marshmallows down and kind of split the distance into thirds, and we're going to use these as kind of joints for our different bracing.
You want to get the marshmallows through the center also, so they don't fall out while bracing.
So the first thing that we're going to do is we're just going to do some simple cross bracing. I'm just using whole spaghetti noodles here for the sake of time, but in the in-class demonstration, obviously, it's going to be to the students' benefit to conserve materials and be cost effective. So they're probably not going to want to just use whole ones, but that's just kind of how I'm going. So,
Like you've seen, spaghetti noodles, they're easy to break off at any point. So the students will find it easy to actually break the noodles and create a cross bracing, which kind of looks like this.
So this is just your standard cross bracing. It's kind of a good, easy way to get you some support in all directions, and you're going to need this to tie your tower together because, as you can see, the unsupported spaghetti noodles are very flimsy, and if you try and get to the 2-foot level, you're going to kind of have some trouble.
Yeah.
There we go. All right, so on this side, we're going to do some chevron bracing.
There we go.
So this is another type of bracing. This is a chevron brace. Basically, it kind of does the same thing, but it uses a connector in the middle to kind of tie it together. So that's just another option. It's really going to be up to your students to kind of just go whatever direction they want to get a stable structure. And we'll demonstrate a couple others. This is just going to be the single connector across the middle. Oh no, it was the one that was supposed to be, you have one like this, and then there was one like that just ran from like here to here.
Here. What was that bracing?
I don't remember what this one was called.
Yeah. It's all just to distribute out the load through the structure to make it more stable. Or like you can see, this is another type of bracing. We just have a bracing.
Yeah. I mean, the big thing is you're going to want to be able to kind of just connect side to side, because you can see already this thing is quite a bit sturdier than what it was when we began.
Yeah.
So we'll just go ahead and we'll finish up the other side. We'll just put some cross bracing here, and then we'll proceed to the next level and try and get this thing to 2 feet.
Yeah. Or what else you want to do is you can use like a couple of more bracings down at the base. So instead of one, you got about 3 spaghetti noodles supporting the entire building, which definitely divides out the load and makes the structure much more stable from the ground up.
So as you can see, things get pretty crowded around the tower, so it's going to be a big thing for communication and make sure that people can work effectively together in such a tight area. So I'm going to go ahead and slide some connector joints on already before we attach the next level, just to kind of make things a little easier. And we've done this a few times, so we've kind of figured out the kind of the most efficient ways to do this.
We will definitely let the kids, the students play around with the material for a bit, so they kind of get an idea how to connect up the spaghetti noodles and the marshmallows before building their tower, so they have some experience.
Alright, let's start with the next one on how do we want to tie these together.
It's up to you. Diagonal bracing across the structure. As you can see now, the tower is less resistant, more resistant to the shaking that's going on, and more stable, even though the height is increased. I think due to the ease of the spaghetti noodles, the way you can break them, you can definitely experiment with a lot of different types of bracing. Because you don't need to really measure the length, you can just look at it and then break it off from there and just go for it, which saves a lot of time. So yeah, this material is very good for the kids.
Alright, we'll get some bracing up here to tie this part together, and then at that point, put the finishing touches on it, and we'll have a tower that is pretty close to 2 feet in height.
Kids also have the option of using gummy bears, which we have not displayed in our video, but they also have the option of using gummy bears instead of marshmallows as connectors. Just to kind of give the finishing touches. Yes, sir. Make a spider. Yes. And as you can see, this tower is approximately 2 feet. Stable and ready to go.
Yeah, so you can see
We'll
here.
just add it up with a little bit more bracing. Make sure that
Alright, so you can see here we've got a tower that is pretty much finished. And it kind of demonstrates a lot of different bracing methods. It kind of shows the freedom you can go as long as you have something that is very stable. So now the last little thing we want to talk about is the testing procedure. So to test it, the first stage of the testing is going to be just to have the tower intact and then have just a desktop fan. It's going to blow across the cross section. If the tower is stable like this one, we're not going to have a lot of movement just from the fan on from the lowest to the highest setting. And then to really test it,
we're gonna put basically a sheet of paper across the tower and blow the fan through it, which will really move the tower,
Yeah.
shake it up.
yeah, and one thing to note when you're doing the testing is to just kind of put a hand on the base. Because these are so light, they'll blow over, and we really want to test the structural integrity of it, and not just whether or
Not
it'll
the
blow,
base.
not just whether it'll blow over. So just put a hand on it. When you do the final testing, put it on low with the fan, and have a piece of paper here, and that increased surface area should be enough to really separate which towers are structurally sound.
Yes. That's it for the demo. Thanks for watching. Do read the instructions for more detail on the demo. Thank you very much.